What's injective? Distinct x mapped to distinct y. So that means no shared y. So for this function, this is square root. Okay, this y to this. These are positive 1. This is negative 1. Distinct x, not the same x, but they map to the same y. So not injective. What about y equal 1x? Okay, look something like this. Distinct x, but one go up, one go down. Yes, this is injective. Okay, then what about this? Well, 1x go to 2y. So this is already not a function. We don't need to talk about, is it injective, is it suggestive? No. But if you want to talk about it, it's not injective. Because again, this is true, right? So you have this 2x give you same y for both the upward and downward value. So not injective. So this is the thing. And then last point, we say nothing on y. We are talking about x. We are talking about from the perspective of x, they map to different y. We didn't say anything on y. Some y can be mapped by none. For example, this function, y is -3 is impossible. So if I consider, we call the Mickey Mouse picture, this is the codomain, okay, which is real number. We only use all the positive part. This guy are missed. So this is called a range or image, right? So here's a two sentence. Range is a subset strictly not equal to the codomain is if and only if there exists some y in codomain. What? This y is not in range, okay? Range, you should spell the whole word. I just lazy, okay? Don't use this. These people may think it's random number generator, okay? So, but anyway, understand this, right? So, same. I just said -3 for y is impossible. Nobody map to -3. So, if and only if, that means I can go up. So, this is the sentence. This is sentence means what? Some y not mapped. So, this is inside injective. So, this has nothing to do with the y. But what's about surjective? It's exactly on the y. All y has been mapped by something from x. So, you want them to be the same. That means this, or you can say this part. What's this part? This part is codomain. Subtract the non-mapped part, right? Let me call it P. You can say that this set subtract this set. If this set have nothing, you can say P is empty set, or you can say this set subtract this set is itself. Same as 3 minus 0 is 3. Okay, something like this. So you can think of this set minus is a subtraction inside. Okay, or you can say this is false. There's no y, they don't map. These are all if and only if. Then if a function is true for this particular condition on the y, then it is surjective. Is this surjective? No, because negative impossible. It is surjective, yes. All the y. So how do you see this? You now start with y. This is y, and then you just look at the left, look at the right, see whether or not it touched something. Yeah, it touched something here because here it touched this part, here it touched this part, here it touched this part, here. Oh, this one is interesting. Here it touched infinity. Then now we have ambiguity. It depends whether or not you accept infinity is in R or not. But we normally said infinity does not belong to R. So very strictly speaking, this function is not surjective because y equals 0 requires what? Requires x is plus or minus infinity. But we don't accept infinity in our R. So nothing can reach this y. So therefore, strictly speaking, this function is not surjective. Okay? And then what about the negative part? It's the same. You just go here. Okay. So what are surjective functions? This is surjective because again, start with y-axis, oh, you see something, happy, you see something. Here's the thing, at this particular point, you see 2x, it doesn't matter, because now we're talking about from the perspective of y, we see something. Now this guy have 2x, that means this guy is not injective, but it is surjective, that's it. And then, what's bijective? Bijective is just both. Let me recall, somebody write this, what's this? This is range of the function, okay? This is range of the function. So, just simple. Simple means you can write anything you want, okay? And if the range is y, it's the same as this black region is the same thing as my codomain because y is my codomain, okay? So that's the same thing. And then injective is just these two are true, okay? And then what's the big deal of bijective? If you have a function from x to y is bijective, then you have a function going back and it's also bijective. That's the big deal. If a function is not bijective, it's possible you cannot go back. For example, this one you cannot go back. Why? If I ask you what x give me y -3, no such x. Therefore, no. This guy, okay, this guy is not bijective. Why? Because it's not injective. 2x give you the same y. Injective saying you cannot have that, so this one is not injective, and because it is not injective, automatically it's not bijective. We don't need to check is this surjective. So that means what? If we want to do the inverse function, so this is a function f, if we want to find the inverse, some error will happen because of this. So if we have bijective function, we can have inverse. Inverse is just write f -1. Some people may confuse this with a power, okay? It is not this, okay? It is inverse, okay? And then the inverse is also bijective. And here's the funny thing. So let's come back to the thing on top. I can have a function. Let's recall what is a function. A function is that, okay, there does not exist x1, x2 that fx1 equal fx2, right? They cannot share the same y, okay? Or if fx1 is fx2 for all x1, x2, then it implies x1 equal x2, right? Okay, these two sentences are like the opposite of each other, right? So we just say that this is the definition of function, and of course it is a relation. So that means x1 r y1 or x2 r y2, and then for the x1 and y1, x2, y2, they inside a set called domain and a set called codomain. They linked together by a relationship R, which is a subset of a Cartesian product between x and y, blah 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 blah. Okay, that's the definition. That means what? This can also be a function. What is this function? Recall the Mickey Mouse picture. This is all the x, this is order y. If I only have a relation, if my relationship is only a diagonal, okay, this x cross x, okay, in this case, if my x, y are the same set, which are all real number, then I can say they are just x to x, right? This diagonal is like what? 1 map to something in 1, 2 map to something in 2, 3 map to something in 3, blah, 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 blah. Okay, now I write a new symbol, diagonal, so I write triangle, and then subscript x. This is a subset of the full Cartesian product, right? This special function has a name called identity. What the heck is it? It's just a very fancy name. It just means whatever thing you give me, I give you the same thing back. So it's called identity. And from the very, very beginning, remember in logic, we have 4 things for unary operator, that is always true, tautology, always false, contradiction, negation, and do nothing. Identity. That's why we have an ID. In matrix, you also have an identity matrix. Okay? Same thing. Number, you have an identity element. 1 multiply anything, give you that thing back. So these 3 things all have something in common. It's like do nothing. So it is basically ID x is x. That's it. And since this is from the set x, we just write this. And then what is composition? Well, ID do nothing, right? So composition of the ID is the same as your function. Notice that the left and right are different. This means first I do f and then I do the ID from y. This means first I do the ID from x and then do the f. In this picture, x and y are the same set, so they are okay. But in some situation, x and y are not the same set, then this is not the same, okay? These 2 meaning is not the same. And then, well, here's a funny part. What is inverse? Inverse, well, we just talked about this, right? We have never said what the heck is this guy, right? This guy is defined from the f. So a function is called inverse if what? You do this composition, give you ID. So that's the meaning of inverse. You need to use this to check is this an inverse. So basically this is how you check a function is inverse or not. And this is from the function point of view. What about from the set theory point of view? Well, set theory point of view is just you have this, okay, x, y, you have this arrow. This is what? A relationship, right? And I told you before you can have inverse, right? What is the inverse? You have all the AB, you flip it back to BA. Now you view this guy back. So for all the arrow in red, map from x to y, you find another arrow going back from y to x. So you can think of it as a mirror image. You can think of it, I flip this like this. So this is exactly this thing. I'm flipping AB. Okay. So in terms of arrow, you are flipping the direction of arrow. Okay. It's like a mirror image. So this is the way you can find inverse by a picture. And then for XY plane, okay, XY plane, you flip like this. Okay. But this is hard to visualize. So anyway. So that's it. And then how do you know a function is 1, 1 on 2? Well, here are the tests. You can read it by yourself later. And here are examples. So is this guy injective? Injective means no 2 x share the same thing. So you just cross something like this. See, do you touch 2 times? No, all of them touch 1 time. This is injective. But here, no x map to this y, not surjective. Okay, this guy, is it injective? Well, if I cross this point, I have 3 cross points, not injective. Is this surjective? Surjective means all the y, I have somebody. Not necessarily 1. I have somebody. That's okay. So for the 0 point, I have 3. Then this is surjective, but not injective. Same for here. This one, not injective, not injective, not injective, not injective. Because all this point cross 2 times. Not surjective. This does not touch. So this function is not injective and not surjective at the same time. Okay. And let me tell you a funny function. This is called ceiling. Ceiling means the top. You can also have floor function. Floor means bottom, right? So the definition is the smallest n in z. That means in integer, such that n larger than your given number. So that means find the smallest number above you. You can call it least upper bound. So the function looks like this. Is this a function? Yeah. Why? A function means you don't have 1x give you 2y. So I cut here. Yeah, 1x give me 1y. Good. I cut here. 1x give me 1y. What about if I cut exactly here? Well, now you see I draw something like this. If I cut exactly like here, the y is defined here, this point, not this point. This point have an empty circle. It means you don't have anything here. Okay. So still 1x give you 1y. Is this surjective? No, because if I have a y value here, 3.5, nothing from x map to me. So this is not surjective. But it is surjective if I define my codomain is just integer. If that means what? I can only have integer as my y. Then this is surjective. So it depends on the context. Okay. If I define my codomain as real number, then 3.5 in y. Nobody map to 3.5, so it is not surjective. But if I say that my codomain is integer, so only 1, 2, 3, 4, 5, -3, -5, then it is surjective. Is this injective? No. Injective means cannot have multiple x share the same value. Wow, this bunch of x all share the same value. So no. It means what? Cut in this, you cannot see more than 1 time. Wow, now here you see many times. So no, right? This is ceiling. Then you also have floor. Floor function means you find the bottom. As an exercise for yourself, think about what is the function looks like for floor.